Hi everyone, in this video I'm going to walk you through a project I built called Internal Company Knowledge Base. This system lets user ask questions directly to Slack and the AI agent will fetch answers from internal company information, making it easy to access the knowledge that you need. It also allows documents uploaded to Google Drive to be added to the database, so the AI always has the latest information to work with. In this tutorial, we will be using n8n, Slack, Google Drive, and Supabase VectorDB to make it all happen. Now you might ask, why are we using Google Drive and Slack in this project? Google Drive serves as the central place where all internal documents are uploaded and managed, like PDFs, Google Docs, or Google Sheets. Slack in this case is where users send a private message directly to the Slack bot. They ask their questions there and the bot replies with the relevant data, which is pulled by the AI agent from the Supabase vector database. And for the AI part, I'm using something called RAG, which stands for Retrieval Augmented Generation. And more specifically, in this tutorial, we will be using contextual RAG. With contextual RAG, we attach meaningful context to every document chunk that goes into our Supabase VectorDB. This makes the AI's responses a lot more accurate than standard RAG. Let me show you what the final result looks like. We've already uploaded a document for demo purpose using our data uploader workflow. Let me show you the PDF file in Google Drive so you can get a sense of what kind of information we are dealing with. This is the document. The document is about Nestle financial data on 2024. Now, I will go into Slack and ask the bot. I will ask, what's the latest financial summary for Q1 based on Nestle financial data on 2024? Then submit. As you can see, the bot replies with exactly what we need. It's pulling the answer from the internal documents we uploaded earlier. The answers are for Q1 2024, Nestle Group reported the following financial summary. This is the result. Yup, this is correct. Let me show you how this all works. Here's the RAG AI data uploader workflow in n8n. This workflow is split into two parts. The first part is data processing and the second part is RAG data upload. Let's start with data processing. We begin with the Google Drive trigger. You will need to create a Google Drive folder and paste the folder URL into the notes input here. Once triggered, we loop through each file in case multiple documents are uploaded at once. Then we have a set node to store the file ID for the documents we'll process. We'll set the file ID here based on the JSON ID that we get from the Google Drive. Next, we use the download file node to fetch the actual file from Google Drive. Make sure the Google file conversion is enabled. We convert Google Docs to PDF and Google Sheets to CSV. Let's ignore the Google Drawings and Google Slides. We don't need them in this project. Then there's a switch node to check the file type. If it's PDF, then we extract the text using extract from PDF node. If it's CSV, we use extract from CSV node. The extracted text becomes the body of our documents for the VectorDB here. Now, in the second part of the workflow, we start by generating metadata for the document using an LLM chain. This gives us the metadata title and description from the extracted text. I'm using Gemini 1.5 Flash model for this, along with the structured output parser to make sure our data format stays consistent. Also, here is the prompt to generate the metadata title and description. The prompt is create metadata title and metadata description based on the documents specified below. Below ## document. Metadata title and metadata description will be used to separate data in vector DP that will be used for RAG. So here is the prompt. Then we go to code node where we split text into chunks. We use two parameters here, chunk size and chunk overlap. Chunk size defines how long each chunk is, and overlap makes sure chunks slightly overlap so we don't lose context between sections. For this demo, I added a limit node to cap it at 20 chunks. This is just for testing. You can remove the limit in production. Next, we generate context for each chunk using another LLM chain. This again use Gemini 1.5 Flash here. This context is what makes our RAG contextual and way more accurate than a standard RAG implementation. Here is the prompt to generate the context. You can copy and paste the prompt from the JSON file that I will share in the YouTube description in this video. We then summarize all the text using a summarize node. We use the separator triple hash, split triple hash. This will be very important later. Then we move to inserting data into Supabase vector DB here. As you can see, we use table name documents. You will need to create the table for this in Supabase. You can follow Supabase guides here. You can follow this URL where you can initialize your own database and create the documents table. Also, we use OpenAI for the text embeddings. If you are not familiar with embeddings, they are vector representations of the text, which is what allows the AI to understand and retrieve relevant info later. After that, we go to data loader. Here we take all the process chunks and insert them into Supabase. We also include metadata like file ID, title, and description. This helps our Slack AI agent to understand and reference documents properly. We also have character text splitter here. The loader also uses the triple hash split triple hash separator to split chunks again using a character text splitter here. Now let's test it. I'm uploading a new file into a Google Drive. The file is a Netflix document. Here is the file. Let's click test workflow. If the Netflix file is downloaded correctly. We limit to 20 chunks so it becomes faster to test. And then it's a success. Let's check the Supabase. Yep, the data's here, the Netflix data. We can see from the description, the title is the Netflix data that we uploaded earlier. Now, since the data is uploaded correctly, let's move on to the Slack AI agent workflow. Here's the Slack AI agent workflow. Let me explain how this works step by step. We start with the Slack trigger node. This watches for any event in the workplace. To connect this, you can follow the Slack credential guide here. You can follow this guide to set up the Slack connection to the NHN. Next is an if node to check whether the message is a private DM. We only process messages sent directly to the bot. If it's a private message, we send the query to the AI agent node here. This AI agent is connected to our Supabase vector store, where all the documents data lives. It uses OpenAI for both embeddings and the chat model. Also, here's the prompt to generate the answer. You are an internal company knowledge assistant. Your job is to answer questions using the files in the vector database. Here how you do it. So here is the prompt. Again, you can copy the prompt using the JSON workflow that I share in this video description. The next node is a Slack node to reply to the user. We send the message using the user ID, by ID, and with the user ID. That way, the response goes back to the right person. That's it. That's the full workflow. Let's run a full demo now. I will message the bot, "Hi, I want to ask something." It replies with, "Of course, please go ahead and ask your questions." Now I will ask, generate the management discussion based on the Netflix document, submit. So the reply is the management discussion from Netflix annual report to the fiscal year ended December and passes several key areas. Super awesome. So it gives me the correct data pulled from the documents we uploaded earlier. Everything works as expected. And again, this is contextual RAG. It gives way better results because we give the AI meaningful context for every document chunk. So that's the full project. We built an automated system that uploads and processes internal documents from the Google Drive, enrich them with the context using AI here, stores everything in a vector database, and let user ask questions directly from Slack and gets accurate answer in real time. Thanks for watching. I hope this video is helpful for you, and I will see you in the next video.